Heyo, here we are back in Stationeers. We're going to try today to work on a little oxygen and a little water gathering. And then we'll see what else we get up to. Don't really have a huge plan for today, but last time we were here we expanded the base. We moved some stuff around. We planted some plants. We automated our grow light, and we automated. We expanded our hydro, I should say. All right, and did we automate this? We did not. So let's automate this today. So this is our air conditioner. It's constantly on, and it's burning hydro. So what we can do is, instead of using a housing and a chip, you can just put a chip right in here. And then you can use these pins here and here, D0, D1, in your programming. Our computer is outside, I believe. So let's go have a look at our computer. So, what we got? We moved all our manufacturing inside last time, right? Okay. Where is the computer? Here is the computer. So, we have the air conditioner. So that is the code for the grow lights. So we have air conditioner, grow light housing, solar housing. So if we import the code that is attached to the air conditioner, there should be none because we haven't programmed it yet. So we're going to need a chip. So let's get a chip. And to do that, we're going to have to go back inside because I forgot that we moved everything inside. Right. So we go back inside. And we need to make a IC10 chip. IC10. Do we have the stuff? We need gold, steel, electrum, and solder. So let's see if we have all that stuff. We have electrum. We have solder or solder, depending on. I've watched a lot of Australians and English guys play this game, and they say solder, not solder, like we say in North America. So I've just gotten into the habit of saying solder. Gold. Yep. And a touch of steel, which we have there. Okay. So we want one IC10 chip. Click that button. We have a splitter there, so if we needed to split up materials, we could. I don't need all this coal that I have on me currently, so I'm just going to put it in here for now. We can always get it later if we need it. Temperature in here is 31 degrees today, so that's why this thing is working overtime. It should say active. So it does say active, which means it's currently working. Where is my tool belt? 98 degrees in there. We have 1.73 megapascals of pressure. So that is our heat. That is our heat sink. Oh, maybe I need to move that partially in here. Huh, I'll have to think about that. So let's grab our chip. Oh, another thing I want to make is a portable light.
Power low.
Power's low. Okay, so if you go into here, there's a portable light right here. Take some iron and some copper. So we've got copper, got iron. Make one of those. This chip, we're just going to pop right in here. Because when we go out and add the code on the computer outside, we can export it right to this chip. So the portable light, we have a large battery. We have one large battery. See if we can make another. The portable light is a light that you can pick up and you can place it on the ground. And see, it stands in the room. But what you can also do with it is you can put it in your jumpsuit. Doesn't make sense, but that's what you can do with it. We're gonna make a battery. We can make a battery. Excellent.
Oxygen low.
Oxygen low. Oh, because our filters are gone. Let's make some filters. So, what you can do is take this large battery here, put it in this light, and then I can turn off this light, and see how our suit, we have hygiene decreasing because our suit and helmet is on. So we want to take our suit helmet off, but then we lose the light. But because we have the portable light, we can still see because it's in our suit. We can take this battery and we can put it in the charger and it will charge up. Now, what is the other thing I wanted to do? We're going to have to charge that up. Oh, our oxygen was low because our filters were dead. Did we make extra filters? We had some outside I saw, but since we're in here, this is where you make your filters. We need some iron. Let's take this out. We got 324 steel. What I'm going to do, I'm going to turn this on. I'm going to set it to 50. And it's going to chop up that into blocks of 50. And then I can store it here for later. And then if I need it in any of the machines, I have, you know, a reasonable amount. So now we chopped all that up in 50. But there was a little bit left over, probably an uneven amount, because we had think 24, I think. So you click that, you get the last bit out, which was 24. There you go. So we can put that actually back in here. Put that in there. This I'm going to chop into 50. This I'm going to chop into 50. And just store it over here. Store that over here. And then I'm going to put the remainder in the electronics machine. 'Cause that's usually where you need electrum and solder, whatever you want to call it. To each their own, I say. So 68 iron. So let's chop that in half. So 32. So we'll take it down to, say, 30. 8 here. 30 there. I put 30 in here. And I'm just going to put this over here. I don't know when I'm going to need it next. And then these guys I'm just going to put back in here. Looks like we're low on gold. We're going to have to do some gold hunting perhaps. If I check my other mining belts. Excuse me. We have a mining backpack as well. Oh, we have lots of ores available to us. So why don't we put this guy here and we can smelt some gold. Put that down here. Put that in there. So just clear up our inventory a bit. And I was making filters. I need a carbon dioxide filter. Two of those. Okay. What I'm going to do is I'm going to put a couple extras here just for emergency purposes. And those are pretty pricey too. Alright, so now I can open up my suit, put these empty ones on the ground, put those in my suit. These ones later on, because they take so much, they take 5 iron to make each one of those. I'm going to keep these garbage ones, so I don't know, I'll just throw them here for now. And then I can, oh, that went in there, I didn't want that to go in there. I'll put them up here. And then what you can do is recycle them and get some of the material back once we make a recycler, which we have yet to do. Now, we've gotten rid of our debuff, which incidentally, if I hadn't talked about it before, when you wear your suit, you get a debuff for, you know, being unclean. And then you become unclean, and then eventually you become unhappy because you're unclean. So when you get that debuff, what happens is you eat or go through food and water much more quickly. So we want to avoid that. Let's open this guy up. Empty him out. We're still 30 degrees in here. This air conditioning should be working better than this. What do we got going on here? So we're at 92. It is slowly cooling up, but it is a large space. And it is just one air conditioner. And these vents aren't in a great spot. I should probably move this vent as well. It's kind of hanging out in open space, because there used to be a wall there, remember? I guess I could grab my wrench. Yeah, we can put it down there. Why not? Maybe it won't let me. Oh yeah, there we go. Okay, good. So that solves that problem. I have to move this thing, I think. I want to put it up one more. So we'll go outside and do that. And then we'll put the code into here. I won't actually do the coding. What I will do is show you the code, which I've already written before on another version of this game and just saved into my library. Because again, I'm not like a super coder. I'm just going to take some of this with me. I don't know if I have a engine generator, solid fuel generator anywhere. Oh, I think so right there. Okay, good. Okay, close up the helmet, go outside, swap out our battery. Okay, so what I'm going to do is I want this guy to be here, so it's out of the environment. Okay, now to the coding. So we're going to inject it into the air conditioner. Currently there is no code in the air conditioner because we imported it. See, nothing imports. So what I can do is I can edit the code, go into my library, and somewhere I have AC coding. I think it is AC Mars Stream Gas Sensor. No, I don't think that's it. Is that it? Let's take a look. We'll bring it in. Alright, let me just pause the game here. So, what we're going to do is we're going to alias the AC sensor. Now, the question is, do we have an AC sensor to alias? I don't even think we do. So we're going to have to go back inside. And by AC sensor, I mean one of these. So this is a gas sensor, but this gas sensor is specific to the airlock. But what we need is we need a sensor inside this room to determine what the air content is or temperature is. So we can make a sensor kit from the electronics sensor kit if we had some iron, which we have. And we can put down one of these sensors here, but we're going to put it over here. And we have our labeler. There's our labeler there. So I'm just going to put that away for now. And then we can just drop this fella anywhere on this line. Just making sure our data is hooked up on our device. So we'll put down a gas sensor here. We'll grab a piece of cable and plug it in. And now we can pull the data from this gas sensor, which we're going to rename AC gas sensor. So we know what sensor it is we're talking about. Goes back over here. There's my skull. We should find a place for this. That's not what I wanted to do. I wanted to rotate. I wonder how you rotate. See? No, Never had to rotate anything before. Well, we'll put it there. Oh, that didn't stay there. No, not there either. What about here? Aha! There's my skull, creepily staring at me. Alright, so we've got an AC gas sensor. We can put this back here. How is our power doing? Power is meh. Could be better. Alright, I just want to make sure we're getting good. Yeah, 400. These are in good shape, they're not damaged. 100%, 400, 400. Yeah, okay, and they're all hooked up. They're all getting data, so they should all be pumping power. I'm just going to give us a little injection of coal power for now. I do want to move these guys. I hate them that they're here. I'd like to have them up higher. Anyway, back to the code. So, edit, pause, library, overwrite. Alright. So, we're going to alias the AC sensor to D0, and that's D0 on the filter, which is inside. We're going to define the AC, just so we don't have to put it on a pin. And define alias is when you use one thing, one AC sensor or one solar panel or one occupancy sensor or one whatever. When you want to use more than one to save into batches, you need to use define. So we're going to define the AC, and that's the hash number. So if I go in here and I bring up air conditioner, there we are. You can see that it has a prefab hash number. So that is a number specific to this device. And that's what we're going to put here so we can reference it. Then we're going to start our program. We're going to yield, which is a pause. We're going to load into the register 0 from the AC sensor, which is the sensor we placed inside, the temperature inside the room. And then we're going to do what's called batch greater than R0, and we're going to set the temperature to 300. Sorry, branch greater than, not batch, branch. So what that means is it's going to read this command, it's going to see what's in R0, which is the temperature, and it's going to say if it's 300 or more than 300, greater than 300, and that's in Kelvin, go to ACON, which is here, ACON. And then what it's going to do is it's going to save batch to the AC mode 1, which means it's going to be, if we go into air conditioner modes, mode 1 is active, which means working. Mode 0 is idle, which means not working. We paused? We are. And then it's going to set it to active, then it's going to jump to start, which is back here, and it will go through again. If it's below 300, it will go to the next line, and it's going to go branch less than R0, so it's going to read the temperature. If it's less than 295, it's going to go to AC off, which is down here. It's going to save batch to the AC, so this is where we define the AC, mode 0, which we know turns off the AC. So it's going to effectively keep it between 295 and 300 Kelvin, which is, I believe, 27 and 24, something like that. And then we'll jump to start, and it'll just go through again, and it'll just keep doing that ad infinitum. And that way, we don't always run it full power all the time. It will keep it between a certain temperature range and save power in the long run. So that's the purpose. So we've loaded this in from our library, and that's the best explanation that I can give. Again, I'm not an expert coder, so if I made any mistakes or I explained it incorrectly, please let me know in the comments. Hopefully that makes sense. If it doesn't, you can ask me some questions and I'll do my best. But like I said, I watch other guys, Splitsy, Navy Old Salt Gamer, Shadow Drake, Cows Are Evil, Panic and Die Gaming. All those guys do coding. I learned it by watching them. And you can watch them and they explain it probably a lot better than I do. So we're going to confirm this. And then what we want to do is export that to our air conditioner. So we're going to export it to the air conditioner. And then we've got power going. So let's see, how much do we have left there? 19 left. Okay, that's good enough for now. And then, remember in here, if I look really close, we have to go and set our pin D0 to AC sensor, because right now it's not on anything, so it won't work. So you need your old screwdriver, and you see how it's flashing? So it's not working, right? And then I go into here, an AC sensor, and I'm gonna pick the AC gas sensor, and now it's working. So we are currently active because it's 28 degrees in here, 29 degrees, so it's heating up. So this will stay on. Once it gets to 24 degrees, I believe I set it for, it will shut off. It'll go into what's called idle. The mode will change from active to idle. You set this down to 20 and you turn it on, and so that forces it to continue working. It will try to get down to 20, but the code will restrict it to stay in between the temperature range that we set. And that's pretty much where we're at. We're at operational temperature efficiency of 99. We're doing 30 moles processed input. I assume that means it's moving 30 moles of gas. Our temperature differential efficiency is 11%. I'm not 100% sure what that means. Pressure efficiency means the pressure, I think, between in here and in here. In here, by I mean these pipes, is 44%. So I think if we should be functional. And if I check in here, we're up to 128. Remember, we were at 90 something before. So it is definitely sucking in the hot air in here, and it's dumping it into here, and now it's going to go outside. It's going to cool at night, so that will allow this gas in here to cool down. So that will allow it to pull more hot air from here into there, and then it will pump it into there, and it will cool down, and we'll just keep moving because we have it radiating out into space. And if we go outside, you can see the temperature outside is minus 35. So if we look at this pipe, it's going to try and cool that down. So it's radiating, you can see 15.4, 15.5, 15.7 millijoules of heat. And as it cools down out here, minus 35 is getting colder, right? As the night goes on, it's going to radiate more joules. And the more joules it radiates, the cooler will keep in there. And then once that gets to a temperature that we're happy with, this will go idle and it will save us power. So that is the automation of the air conditioning. Now, what else we want to do? Well, what else I want to do is I want to get... I need to put water in here because we need water for our plants. We need water to drink. We have ice, but how do you make the ice into water? So we're going to do that. And we also need to put carbon dioxide in here because the plants that we're growing here use carbon dioxide and produce oxygen. But there's only a finite amount of carbon dioxide inside that room. Now, if you check the atmosphere on Mars, which is relatively friendly, you can see there's oxygen at 1.4%, nitrogen at 2.9%, and look at that, 95% carbon dioxide and a tiny bit of pollutant. So, what we can do, we don't want to open our helmet, that's for sure, is we can suck some gas from out here in the atmosphere slowly into the room. Or we can set up an ice crusher and crush oxide and then pump it into the room. We can also use that to fill up our oxygen container because eventually we're going to run out. So we need to find a source for that. So that's what we're going to do. So we're going to need to go inside. We're going to need some pipes. Might as well take those in with me. Anything else here that I need? I don't think so. Active vent. We'll probably need an active vent, so we might as well bring that with us. Power control. We're not going to need that. Alright, so what we're going to need to do, we don't need this on anymore, so it's just a drain on power, so we'll turn that off. I'm going to turn this guy back on, get us some nighttime power. These guys are not moving. If we get a storm, these guys will certainly jack up the power. Like I said, I do want to raise them off the ground. I don't know if it makes a difference, but I want to keep this area open. I guess I could put frames there and then slip through this spot. I think that's worry about that another time. Power, okay, we're good on power, so I'm just gonna turn this off, save that coal. We don't need anything here. How's the fuel canister doing? Okay, it's got lots. So let's go inside. Oh, I forgot to smelt that gold. That may be an issue. So, we're going to want to put an ice crusher, I think, here. To get the water, we can put one here. We just put some pipes and it'll run through here into here. We have lots of water. We have 38 liters of water. But that will go surprisingly quick. Let's open up this. So now we can take our suit off. That way we avoid getting unclean. Or as some other guys call it, stinky pants. So we're going to drink some water. Now we're growing wheat. The reason we're growing wheat is because we're going to grow cereal bars. Which we probably already did. Oh, but we're going to eat the potatoes first. Yeah, we want to get rid of those potatoes. We've got 15 grams of flour there. I don't think we're going to get to those eggs in time to save them. I said that's a whole other kit caboodle. Okay, so put that in there. Close that. Top up our water. Turn that off, save some power. Alright, now what we need is an ice crusher, which I think is made in here. Ice? No, it is not. So then it must be in here. Yes, I could just look it up, I know. Ice crusher, there you go. So we need iron, gold, and copper. Well, where's all our gold? I think it's all in here. So let's take out some copper. Put that in there. And we've got just 10 iron. Let's put this 8 iron that we have in there. And I'm going to grab some iron. I know we have extra iron in here. We'll smelt that up too. We have food and water. We're not in a horrible shape for food and water. But, you know. Oh, look at... Oh, those are the empty ones, yeah. But I just, you know, we're going to grow our own, so that's our emergency supply. We need 2 ice crushers. So we need an ice crusher here for water, and we need an ice crusher here for oxygen, because we're going to have to deal with that eventually. So let's print an ice crusher. Well, that's printing that. We can put this in here, so we don't lose it. We're gonna need more iron because we're gonna need pipes for all this stuff. We have liquid pipes here. 16, that's good. Okay, so there's one. So I'm probably gonna put the ice crusher outside here. I'm probably gonna put it outside there. Did we use up all our copper? Because we're gonna need some more cables, I think. Okay, so we've got some cables, got some pipes. We're gonna need these pipes. And what I'm gonna do is, I haven't hooked up these guys yet. Might as well hook them up now. That's going to drain our water significantly. See, 26. We had 38 liters before. And then the ice crusher is going to come in. I guess we can put it there. We'll see. Right. And we've got power there, should we need it. And then the other ice crusher is going to go here, but we need a connector. Right, because we have a connector out here for this one and a connector for that one, so those are the 2 that we came with, so we'll make one of those. 5 iron. Oh, we gotta make some iron. Okay, and we're out of space, so I'm gonna put this, I have to have it come in from the outside. I need to be able to get to the fridge. We may have to move our stacker. Or I can move a shelf. Decisions. Alright. Let's move the stacker. It's easy enough to move, and we can put it up later. Actually, I'm gonna need cable for the ice crusher. Just gonna put that there for now, so it's out of my inventory, and then I'll come back and get it later. Bring that with me for now. Let's go put our ice crushers up outside. What's the temperature in here now? See, now we're down to 23 degrees, and we are still active. I'm not sure what we set it at, but I think it'll stop at 22, but we'll see. Oh, gonna need our suit because we're going outside. As far as I know, we're not Superman. Oh, so these are doing well. They are thriving towards seeding. Excellent. So I want to get all of these grown and then plant them all in here, and then we'll have more than enough to make food. We have to make some gold and some iron. And sun's coming up, so it's still cold enough that we can do this if we hurry. So I want to split. I only wanted 4, but that'll do. Okay, get some temperature in there. That's more than enough. We're just doing a little bit of iron and a little bit of gold. Some of that pressure. So we don't have an explosion later. Okay, now, like I said, we need to put down ice crusher. There's your ice crusher. On the back, you have data. On the front, you have power. You have a liquid pipe at the middle, and you have a gas pipe at the top. So probably gonna want to put it, let's say, here. If I put it here, can I get around? Pretty tight. That's why I need to move these. Maybe I can move that closer. That there. Is it a... Yes. Okay, and to finish building it, is it cables? Welding torch and iron sheet required to continue construction. Well, we're gonna have to go find some iron sheets. There's some iron sheets, so let's put this here for now. We'll grab those iron sheets, trade that out, switch to a welding torch. I'm gonna put my plant analyzer there, put that there for now. Don't need those heavy cables. Okay, so. Gas? I'm out of fuel. Oh. Let's just borrow this guy. What I'll do is I'll take this empty canister over here. Just put those back temporarily because I need to get my wrench. So I can unhook this. And then where's the entrance? There. That in there. Okay. Reconnect that. This fella I'm gonna put in here. Grab the iron sheets back. And so now what do we need? 2 cable coil. Okay, so the way this works is you put your ice in there, it grinds it up, it needs power of course. And of course whenever you join cables together you need your clippers. Okay, so now we've got power. So now liquid is going to come out here and gas is going to come out there. Now we're going to crush ice. Not space ice, just regular ice. If I can find it. Space ice. Okay, I cannot find ice. Water. The reason I'm looking this up is I want to see what the off gas is. If it's just water or if there's a gas that comes off of it. Over here, we're going to put our other ice crusher because this is where we're going to do our oxygen. So let's put this guy here. Now I know for certain that oxide, this guy here, off gases oxygen and nitrogen. So it doesn't off gas a liquid, so we're not concerned about the liquid pipes. What we are going to be concerned about is the nitrogen. So we can put nitrogen in there and use a nitrogen filter in our suit. Nitrogen is good for soybeans. So I'm not really terribly upset if we mix nitrogen in with our oxygen. If we wanted to keep it perfectly pure, what I would do is I would run it into a filter, atmospheric, so where the same product, oh there, look, it shut off. That's perfect, that's what we want. And I would run it through a filter, I would filter off the nitrogen and store it somewhere else in a tank, maybe up on the roof, and then pump in just pure oxygen. But I don't mind having the nitrogen in my suit because I can just put a nitrogen filter in and it really doesn't hurt. So we're just going to connect it directly. So I'm going to put this guy here. I'm going to bring him down. Later on, we're going to switch this to insulated pipes. That way then we don't lose heat. And then we just need to bring some cables out to hook up the power. Okay, and then there we have power. And you just put your oxide in there and it will pump the gas into the container. So, what I'm gonna do now, I don't need an active vent. Well, perhaps I do. Bring it with me just in case. Network analyzer lock. Okay, I don't need any of these things. So let's go inside. Power's good. I was just checking on the water pipes to see the water pipe situation. Okay, I'm just gonna put my suit in the locker here for now. Okay, what do we got? Seeds yet? Thriving towards seeding, thriving towards seeding, thrives. We don't have seeds yet, so we're gonna wait till we get seeds. Do we? I know we have some seeds. We have 9 wheat seeds. We've got plenty of wheat seeds, so we're good in that perspective. Temperature. What's the temperature in here? Temperature is 22 degrees, so that's probably when it shuts off, when it gets to 22 degrees. So now it'll stay. See, it's in idle now. It's not using any energy, which is what we want. Now, I think what I can do is just grab this fella here, hook him into here. Need some more water pipes. Okay, so now, I look here, we have $25 liters of water. We have in the belt here ice water. That's what we're going to use to make water. But I wanted to find out here, ice water, that's what we want. So, yes, see, it does release nitrogen, least water, and then nitrogen. So the nitrogen is going to come out of the back of there. And I think what I'll do is I'll just pump it directly into the room. So I can just put this attached to... here. And I'm gonna need a vent. Okay, so now that will just pump the nitrogen right into the room. Again, nitrogen won't kill you. It's a, good for cooling gas. Some plants like it, and it'll just help keep the pressure up in the room. Now we're going to bring our oxygen in through here. We're going to need what's called a utility. Gas utility. Okay. Put our gold in there. And we're going to need a pressure regulator. The utility's done. Well, the pressure regulator is a kit. It makes a back pressure regulator, and I'll show you the other stuff. So pause, pressure, regulator kit. So it makes pressure regulator, pressure valve, back pressure regulator, purge valve. This moves pressure from one point to another. This keeps pressure. So if you wanted to keep pressure in the room at a certain temperature or a certain pressure, so let's say we wanted to keep it at 54 kilopascals in this room, you put this in on a vent, set it to 54. If the pressure ever gets above 54, it will push the excess gas out. This does the reverse. Pressurant valve and purge valve. This purges gas from a line, and this allows you to pressure, I think, liquid pipes to put a gas in. So when you use liquid in liquid pipes and you get into more complicated things like phase change, you want to keep the pressure in the pipe at a certain pressure so you can pump gas into a liquid pipe to keep the pressure so that phase change happens. It's a more advanced thing that we may get into in another video. At this point, we just want a pressure regulator, which is this guy right here. And the reason we want that is what I'm going to do is I'm going to put down a gas tank storage. And we're going to put the gas into here. Just have to figure out where to put it, because I need to have room for this fella. Because I can't put it directly attached. I think I need to have a pipe in between. Yeah, see, it won't let me do that. So what I can do is I have to pick this guy up. Oh, but now I have this wire in the way. Now it becomes complicated. Let's think. How do I want to do this? Well, first I'm gonna have to pick it up regardless. I'm gonna have the gas come from there into here, and then it's gonna go into there. Can I put this here? And then I would need to put a pipe here. That's not going to work because I need to put this here, but this line is in the way. I might be able to move that line. So if I move that pipe there, this here. What I wanted to do is I wanted to pump into there. And then my power is there. Oh, actually that works out well, surprisingly. I can power it from there. And then I want to, of course, going to need more pipe, which I don't have. So I'm going to pump it into there, and I'm going to put my oxygen canister here. On this connector. Okay, so now I need some pipe, which we get from the pipe vendor. Okay, so what I've done is created this monstrosity is I need to hook up the power outside. So I'm going to put oxide in the grinder. It's going to crush it and it's going to turn it into gas, nitrogen, and oxygen. It's going to fill this pipe and then fill this guy up. And then when I want to fill up my oxygen in my suit canister, which is here, I can just take my oxygen canister and put it in there and then turn this on. I can set this to 5,000 kilopascals. And now it will pump 5,000 kilopascals into my oxygen tank. Alright, so let's make another canister. I would paint it white, but I don't have any white paint. Oh, I could make white paint. Paint. I need 1 iron. Get it from here. Okay, so I'm just going to put this back in here so we don't lose it. Of course, I forgot to close the hatch. Okay, so we're good there. We're still idle. Temperature's fine in here. Do we have seeds yet? Ah, we do. So let's deal with that. Harvest wheat seed. Yes. 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 Yep. Mm-hmm. 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 So what I'm going to do is just plant these seeds in here. We have lots of seeds. Then, holding down the Alt key, 1, 2, 3, 4, 5. I'm just going to plant one in there. Okay, so we've got 28 wheat. We will turn that on, put the wheat in there. Turn it into flour. 140 flour. We'll add that to our flour stock. While we're here, we'll eat the rest of this potato. Alright. Now, what we're going to do is we can see we have 4.82 megapascals of oxygen in there. 1.53 kilomoles of oxygen. Once I put the oxide in this machine, it's going to put it in there, and it's also going to dump nitrogen in there, which is when we'll start to use the nitrogen filter in our suit. And then when I put water in here, we have 25 liters of water. So we have 24.8 liters of liquid water, and then some gas, so 12 kilopascals, but 24.8 liters. All right, so let's just remember that number, because we're going to put some ice in here. It should go in here and then fill this up. Now, these guys hold a lot of water, so it may not, it's 48 liters. I think it's in each one. So we'll just have to keep an eye on how much it is. 48.4 and 24.8. Okay, you guys remember those numbers, because I'm not going to. Close our helmet, go outside. How's our power? Our power's doing okay. Alright, so this is going to suck up a lot of power. So we're going to put some ice in here. It's going to grind it, it's going to turn it into water, and it's going to put it in there. So I can look at this machine, and you see it's creating nitrogen, it's creating water. It will build up a certain amount of water, and then it will inject it into it. It doesn't inject it right away. We may need to actually go get more ice before we get the right amount. And then this one, once we hook up the power, of course, we're going to do the same thing, except we're going to use oxide. Normally what I would do is I will at some point, I would paint this blue to match oxide and paint this white to match ice water. So we'll put some oxide in here. Turn that on, put that in there. Like I said, that's going to chew up a lot of power. So to counterbalance that, I'll just turn this on and use up some of that coal. So it's chugging away. You can see it's moving, the gears are grinding. This one, the gears are grinding. So we're pumping hopefully oxygen into there, and we're pumping water into this system here. And that's the plan. Oh, well, we're out here. I'm just going to paint this guy white. That's why I brought it outside, because when you paint, you release pollutant. So I didn't want to release pollutant into the base. There. Okay, still chugging away, so that's good. And that's still chugging away. Power is green. Power is blue, so let's turn this fella off so we don't waste a little bit of coal that we have left. I guess I didn't need... Oh, I know why I thought I wanted... So what happens is when these plants produce lots of oxygen, like too much oxygen, I can use this active vent hooked up to that system there to suck the oxygen out of the room and put it in there. Because the plants eventually will allow me to convert carbon dioxide into oxygen, which I can then breathe. But when you're going to need a source of carbon dioxide, where are we going to get it? Well, we get carbon dioxide from our waste canister, but that's really not a lot. So what I'm going to propose is we will hook up some vents, maybe up here on the ceiling, and I will put a pressure regulator in the room, and I will have it pull pressure, pull the oxygen from out here into the room, and then I can hook it up to a back pressure regulator so that it keeps it at a certain pressure. It will draw in, unfortunately, a little bit of pollutant, but not too much. Like, that amount of pollutant won't affect the plants in a negative fashion, so we can survive with that. And then I'm always cycling carbon dioxide into the room, which will get turned into oxygen. And I can, of course, adjust it as required with the pressure regulator and the back pressure regulator. But that's what we'll do next time we play. Okay, so you can see we're done with our oxide, so we can turn that off to save some power. We should be done with our water. We'll turn that off to save some power. And let's head inside and see how successful we were. Oh, look. We're at full power. Nice. Well, since we're at full power, we might as well check our portable light. 50%, so we'll turn that on. And our suit battery is okay. See, we don't have this light on anymore, so we're not wasting suit battery. That's why it lasts a lot longer. Suit we can take off. Alright, so how much water do we have now? We have 27 liters of water. I think we were at 24.8 if I recall. And 51.8. So we see we increased our water. So we have water. Now in the room, we have more pressure, 56. We were at 54 before. That's because the nitrogen that got injected from there. In here we have 6.7 megapascals. We're at a dangerously high level of pressure before that thing's going to explode. So we don't want to pump any more into there. But that's good. That's what we wanted. And the reason we put this here is I can take this canister, put it in there. You can see it has 0 in. Flick this guy on, and now it will start to fill it up, and it'll cap out at 5,000. So if I put this here, you will see we are getting nitrogen and oxygen in there, and we have nitrogen and oxygen in this tank now because the oxide pumped nitrogen in there. But that's okay because we have a nitrogen filter in our suit. So that is going to pop up to 5 megapascals, which it is at, and I can now just take this oxygen guy and put that in there. And boom, that'll pump up to 5. This lowers the pressure in here so it's not going to explode. And then once it gets to 5, it'll stop. And then I can just turn this guy off to save power. And now when I want to swap, I just boom, swap. And I can empty this guy in here. And put that back there. Okay, so what did we accomplish? We got our AC automated, so it keeps the temperature in here nice. It's at 25 degrees in here right now. Once it gets to about 27, it'll turn back on. And so we're conserving power that way. We've grown a bunch of food. We now have oxygen source because we could just take ice and put it in there and create oxygen until our plants are up to producing enough oxygen for our base. We now have the ability to get ice water and pump it in here, and then we have a supply of water. So we've got water, we've got oxygen, we've got temperature control, we've got food growing. So we're in actually really good shape. We're in a stable position where we now have basically a complete tier 1 starter base. So at this point, what we'll do is start to upgrade. Advanced furnaces, automation. We're going to put in something to modify the atmosphere in here so we have a constant amount of CO2. Because you can see we have right now only 5.9 moles, and you can see it's going down because these plants are sucking it up and they're spitting out oxygen. If I switch to my plant analyzer, you can see at the bottom we have 1% carbon dioxide required. Present, we only have 3.2%. So we're going to need a source of carbon dioxide for those plants. Pollutant, we have 112 pascals present in the room. And we're limited to 979 pascals. So we're about 10% of what we need. Volatiles, we don't have any, so that's good. So if I switch to the atmospheric, you see we have a little bit of pollutant in the room. And we can certainly get rid of that. I can put in, if I had to, a filter version of this device from the atmospherics kit. I could put it in and I could set it up to suck all the pollutant out. But we're going to let pollutant in anyway because we're going to use that method I was discussing. But we'll do that next time. we play. Alright, so I'm just going to put this here so it's ready for next time. Put that there. Don't need that. And I think that's it. Oh, yeah, so I can take this guy, as I was saying, and I can put it, say, here. And I could take a pipe and I could put it here. I would need one more pipe, which I don't have. And then I can hook it up to power, and I can suck the air out of here into this system if I had too much oxygen in here. But the other thing we have to do is find a place for this stacker. Well, I'm thinking we need it for this here. What if I put it there? That wouldn't hurt. We can put it there. Why not? The reason I want it here, set it to 50, is because if I take this flour, I can put it in there, and it will spit out blocks of 50. One block of 50 in the microwave makes one cereal bar. Okay, perfect. So, that's where we're at. We have, as I said, air conditioning. We don't have to worry about the temperature. That's going to make the plants happy. We have a source of water. If we run out of water, we can get ice, put it in the crusher, get more water. If we need oxygen, we can put oxide in the crusher, get more oxygen, get some more nitrogen. So like I said, we're in really good shape. We have food, we have water, we have power. We're doing well. All right, so we're going to end it there. Thank you for watching. Please like and subscribe. Add any comments, any ideas. If I did anything that was silly, please let me know. If you have any suggestions, please let me know. Or if you have any comments, please let me know. Or any questions. And I will do my best to answer them. I am new at this, so the more likes, comments, the better. Okay, and that's it. Have a great day.